So in this video, we're going to be learning about chat models in LangChain. Chat models in LangChain. Now, to fully understand what chat models help us to do in LangChain, we first have to understand LLMs. LLMs, these are large language models. And we are often familiar with them from providers like OpenAI, Gemini by Google, and Claude from Anthropic. So OpenAI gives us the GPTs, the GPT models. Gemini or Google gives us Gemini models, so that's just this. And Anthropic gives us Claude. Anthropic gives us Claude. Those are the major providers. There are still other ones like Mistral and others. So they are LLMs. And LLMs started as just these basic models for generation. They didn't really start as the conversational, powerful, multimodal models we know them to be of today. Just send in a prompt and get a response. And that's basically everything. So I can say, summarize this bit of text or generate a poem and stuff like that. So during that time, LangChain had an LLM package. There's a package in LangChain called LLM. It's deprecated now. So it had an LLM package, which served as a wrapper for these very early LLMs from ChatGPT and the rest, like the 3.2 or something. Yeah, GPT 3.2. I think GPT 3.5 was probably the first conversational model. So LangChain had this LLM wrapper. But when models started becoming more conversational, started becoming smarter, started having things like memory, and started being multimodal, meaning that they can take in different types of input, not just text. They can take images, they can take audio. We then add chat models. So LangChain had to create chat models. So this is the LangChain side of things. And this is the provider side of things. So when it was just very, very simple LLMs, LangChain had this LLM package. And now, with these more powerful models, the multimodal models, the conversational models, the models that can use memory and do all sorts of functions like tool calling, function calling, and stuff like that, from the providers, that's when we started having like your GPT 3.5, your GPT 4, we had 4.0, 01, and now we're at 03. As at the time of recording this video, we're at 03. Probably the time you're watching this video, there's a newer model out, but we're at 03. Then Gemini, I think it's kind of started from 1.0 Pro, 1.5 Flash, 1.5 Pro, and you get the gist. So LangChain had to come up with chat models. Now, what are chat models, basically? What are chat models? Are they the same models as this? And the answer is no. But to understand that, let me just create a new board and let's switch to that. So let us look at what chat models really do in LangChain. So what happens is that you have your provider, let's say OpenAI. You have your provider, let me put my pen. So you have your provider, let's say OpenAI. And they are the ones that own the actual models. So you have OpenAI and they give you your model. Let's say GPT 4. So OpenAI gives you GPT 4. Now, developers want to use this model to make AI-powered applications. So what do providers like OpenAI do? They create an API. So an application programming interface. They create an API, a RESTful API that developers can communicate with and use these models. So developers, that's you as a developer with your system, can then call these models through the API provided by the LLM provider. So with the API, you can interact with the model and start having AI-powered features in your applications. Now, the problem was this. OpenAI has its own API with different definitions and different rules as to how you can work with it. Gemini, which is by Google, also had their own API, also with a different structure and different ways to make use of it. And Claude and every other API provider for their LLM have different API rules and different ways you can work with these APIs, even how you authenticate with them and all that. Now, for a developer, that can be a total nightmare. Because let's say you build your application to run on GPT-4 by OpenAI. You build your application to run on GPT-4 by OpenAI. Then you realize that you are better off going with Gemini. You realize you're better off going with Gemini. You have to rewrite all the code that interacts with the provider's API. You have to write all the code because Gemini doesn't work the same way as OpenAI's API. Gemini API doesn't work the same way as the OpenAI API. Or let's say you discover that a subset of your application will be better off using Claude models by Anthropic. You have to learn how the Claude API works, how the contract works, what are the rules, how to interact with it. And at the end of the day, you have to maintain so many knowledge bases. And I must tell you, as someone that was once working with OpenAI, I think it was their SDK, the 3.x SDKs. I was working with OpenAI 3.x SDKs, and they switched it to 4 in between a particular course I was working on. They switched it to 4, and I had to re-record all the videos to make everything compatible with 4. Like there can be breaking changes, there can be serious breaking changes. So the LangChain team decided to create a module in their framework called chat models. Yeah, a module within their framework called chat models. And what this module does is that it harmonizes all the APIs of these different providers. It harmonizes all the APIs of these different providers so that all you have to do is pick a provider, give LangChain your API key, and from there, every single code you write to generate text, to process images, to stream, everything is the same across board. The code you write for your Gemini models is the same code you write for your OpenAI models, and the same code you write for your Claude models by Anthropic. So that's what chat models do. Chat models are a wrapper. Chat models are a wrapper around all your different LLM providers. So OpenAI, that's not how OpenAI is spelled. So OpenAI, Google, Gemini, and there was a time, and I think they still do, they support Google Vertex also. So Google Gemini or Vertex, Claude, Mistral, LLMs from Grok. Chat models support everything. They provide a single interface for you as the developer writing your application to interact with any of these models. So they unify the entire API interface. They unify it. Because even with these providers, they provide the RESTful API, so you can communicate with the RESTful API directly, even though that can be very, very cumbersome. So only use it in very specialized use cases that you just want to work with the API, or the RESTful API. But conveniently, they provide client SDKs. They provide client SDKs to work with all these tools. And when you want to work with any of them, you have to actually install the client SDK when you want to work with them directly in code. The SDKs provide a simpler way to work with this, but they are still different for each provider. The SDKs are still different for each provider. But with LangChain, you can just install the LangChain. Once you have LangChain installed, you install the LangChain package for your specific provider. You set it up, and from there, every single code you write is the same for Grok, is the same for OpenAI, it's the same for Claude models by Anthropic, and the same thing for Google. So that's what chat models really do. So they abstract all that for you. They unify the entire interface. Yeah, they unify the interface. That's the very first thing. And they don't just unify the interface. They also abstract a lot of complexities. So first, you have unification of APIs. Then they also abstract complexities. They also abstract complexities. These APIs, even when you're working with the SDKs, it can get really cumbersome. And there are some things that you might need to write over and over. You have a lot of repetition. You got things you have to write over and over and over again. But with LangChain provides this interface. We're going to be looking at something called the runnable later, which is a class that a lot of modules in LangChain implement that just gives you most of the common interactions you can have with any kind of part of an LLM's API. And it even has a Fluent interface where you can get to like compose different components together, but more on that later. So it abstracts complexities. For example, if you want to communicate with, I think, OpenAI, if you want to generate text, you have to do something like client.create. I think completions or something. Sorry, I might not be getting this right because I didn't cram the API, but just something this long. Client.create.completions and stuff like that. And then you pass in your prompt. But with LangChain, you can just do model.invoke. And you pass in your prompt. Now, this call to generate a response from OpenAI SDK is different for the Gemini SDK. For Gemini SDK, it's like there's a function called generate content. Then for Claude, it's also different. But when you use a LangChain wrapper, all you have to do is say model.invoke. That's your model, and call the invoke function, which you're going to be looking at in a later video. Call the invoke function on your prompt, and you just get your response. If you want to stream content, it's a whole different ball game for every single SDK. But with LangChain, you just simply say, replace invoke with stream. With the stream function. Replace invoke with stream. Sorry, I didn't write that correctly. Let me write it so that you can see it better. Yeah. So model.stream. Just call model.stream. Yeah. And you get an iterator that you can iterate over, and you can continue to output your tokens as they come out. So yeah. Chat models do all these things for you so that you can have a unified interface to work with language models, and so that it helps you abstract a lot of complexities with working with these models across board. It also does things like performance optimizations. So there are a lot of performance optimizations under the hood, especially with things like batching requests and stuff like that. You also get composability. Yeah, it's the chat models have an interface. Like I told you, we're going to be learning about the runnable interface soon. That's an interface that can help you compose components together. So if you want to compose your model, maybe you want to plug in your model to something like a vector store, or you want to plug it to something like memory, the interface provided by LangChain chat models, or LangChain in general, which chat models implement, will help you to easily do all that composition. Yeah. And let me see, do we have any other thing? Yeah, and another wonderful thing it does, it provides alternative implementations for some features that are not available on some chat models yet. Yeah. It does that. For example, context caching. Even though there are some models that don't have a context caching feature. For example, I remember during the time of Gemini 1.0 Pro, there was no context caching. But LangChain had its own context caching feature that can work with the chat models, that can help you to cache responses from your models to make sure that when you have repeated calls that your clients make, that your users make, users of your application, they have repeated calls they make. If it's cached, then it doesn't need to make a round trip. It doesn't make a trip to the language model API for that particular response, which will save you a whole lot. It will save you a whole lot of money. So LangChain had its own implementation of context caching, which works with the chat model wrapper. And Gemini didn't have context caching then. And probably there are still some models now that you might want to use that don't have context caching. There are some local models that don't have context caching, but LangChain already has an implementation of that through chat models. So that's another wonderful thing that chat models help you to do. So those are chat models in LangChain. They're basically a wrapper that helps you interface with the APIs of your LLM providers. And what it does is that it provides a unified interface for working with all these APIs, because all these APIs have different rules and different contracts to work with them. But with LangChain chat models, you can work with them using the same interface, and you can also program with them using the same interface. In the next video,